Alright. So, the other day you guys had a worksheet that gave you notes on projectile motion. So, we want to go over some details about that. First of all, projectile motion is simply any type of math problem that deals with throwing something up in the air and it coming down. Remember, this is Newton's law of gravity, which is what goes up must come down. So if you think about throwing something in the air or projecting something in the air, it follows this pattern. It goes up and then it comes down over a period of time. This time is usually measured in seconds, and then we are looking at some type of height. Usually in math, we're talking about feet or inches or meters. So, you were talking about the height of an object after so many seconds. Now, because we're talking about a realistic application, we're not going to look at the negative side of time because we already know in math that time is never negative. So when you're talking about real life applications, you're only dealing with the positive side of time. You can't deal with the negative part of time, even if your graph goes over into the negative part of the x-axis. So we're going to look at this example. I have one example here that I'm going to go over in this video. You guys can watch this video as many times as you want to understand. We're going to be going back and forth from this paper to the calculator, so you need to make sure you pay attention to the strokes that I am doing. This problem says, suppose Nick throws a baseball in the air with an initial upward velocity of 29 feet per second and initial height of 6 feet. So that means he's starting or he's holding the ball out of the air at 6 feet, and the speed of the ball is going 29 feet every second. They normally give you a formula in your problem that gives you the velocity or the height of the ball. And that formula for this problem is negative 16t squared plus 29t plus 6. T and h are replacements for x and y. This is, you can replace this and say y equals negative 16x squared plus 29x plus 6. So x is your time in seconds and y is your feet. So anytime they give us an equation in a word problem, we use our calculator. We go to y equals. Now in y equals, we want to type in the equation. Negative 16x squared plus 29x plus 6. Alright? Now we want to graph that. Now when we look at our graph, I cannot see the maximum height. That means my window is too small. So I go to window, and my Y max needs to change. It needs to be bigger so that I can see it. So we're talking about throwing a ball in the air in feet. I don't think anybody can throw it past 25 feet in the air unless you're an awesome baseball player. So now when I graph it, I can actually see the vertex of the parabola. Is this parabola a maximum or a minimum? It has a sad face, so it has maximum problems. So we have a maximum. So then we want to go to second. Cameron, quit interrupting my video. Second trace. And we want to go to the number 4 for maximum. You use your arrows to get as close to the vertex as possible. You hit enter on the left side. And you scroll over. Enter on the right side. When it says guess, you have to hit enter one more time. It should say maximum across the bottom of your screen. And this is the maximum point. X is 0.906. Y is 19.14. Now the question on the problem asks you, what is the maximum height? Which one of these variables represent height? X or Y? Y. So the maximum height is 19.14 feet. Alright. It says, when does the ball reach its maximum height? Well, if the maximum height is 19.14, then we need to know the x value for that, which is 0.91. You can round to the hundredths place. So it reaches it at 0.91 seconds. That's the answer to the second question. Alright, now, C says, how long does it take for the ball to hit the ground? Think logically, what would the height of the ball be if it's on the ground? The height is going to be 0. So to find the zeros, you go back to second, trace, and you have this option right here that says 0. So you hit option 2. Now we don't want to know this 0. This is when he throws it up in the air. We want to know the 0 right here when the ball hits the ground. So we want to scroll. Uh-oh, went too far. Left bound will be on top. So you hit enter. Right bound is underneath. Enter. Uh-oh, I made a mistake. I got to go over. Back again. Number 2. Left bound is on top. Enter. Right bound. Enter. And hit enter again. When y equals 0, x is equal to 2. So that is 2 seconds. It takes 2 seconds for it to hit the ground. What does h of 1.2 represent? Remember, this is function notation. This is the value of x. You have 2 options here. You can do it manually by plugging this in for t and solving for the height. Or your calculator, you go back to second, trace, and if you hit option 1 for value, you can actually type in 1.2 and hit enter, and it tells you the y value when x is 1.2. So at 1.2 seconds, the height is 17.76. That is how you do projectile motion.